Good morning, Cappuccino. Welcome to our new learning environment, which is teachers have been instructed that we are now going to be holding you accountable for the work that you've been doing. So prior to now, there were a lot of students who did not have internet or computer access, and so teachers were asked to take it easy on students who weren't turning things in. But now that has lifted, and it's time for everybody to get to work, right? So we are going to be doing some calculus, and I am going to be having you turn in your warm-ups. It's not just going to be the first 6 people who turn it in so they can get extra credit. Everybody's going to be turning in your warm-up. So warm-ups are going to be worth 10 points. Okay, so there's going to be a new structure for how points are awarded. Warm-ups are going to be worth 10 points. Notes are going to be worth 10 points. You'll also be uploading those still. And then math-based assignments are going to be worth 30 points. So each day you have the potential for 50 points. Holy cow. Another thing is there will not be a formal final exam. The final exam will be just like another class assignment. So more details to come on that. But right now we are going to get started with our warm-up for today. And then there will be a second video for notes. So you'll do your warm-up, you'll upload your answer, and then you'll do your notes, you'll upload your answer, and then you'll get to go on either the math-based assignment or on a book assignment. So for today, I haven't set up the assignment yet, but I'm going to try and make it a math-based assignment, but I haven't actually looked at the problems there. So it might be a book assignment. We shall see. All right, so what we're going to be doing today, this week, we're going to be focusing on volume. So volume of revolution. So we've done this before, so you can look it up in your notes. Also, it's in your formula packet, so grab that handy-dandy formula packet, the calculus page, and find the formula for volume of revolution. And for our warm-up, we're going to be doing around the x-axis, and then we're going to take notes on doing it around the y-axis. Okay, and then you'll be practicing doing volumes of revolution around the y-axis. But this one is around the x-axis. So we've done this before, and the formula is in the formula packet. And I want you to try and do it. Everybody should be able to do it on a calculator. And if you can also do it by hand, that would be great. So give it a try, doing it by hand. You might find that you come up with some pretty unbearable fractions. So at that point, if you want to grab a calculator to help you with the fractions, by all means, go ahead and do that. But I'm just thinking about preparing everybody for college next year. Those of you, which is most of you who are going to college, will be taking calculus in college and looking at different professors' syllabi. Some of them won't let you use a calculator, so you got to be able to do this by hand. And hopefully most of you will have professors who will allow you to use the calculator because, frankly, that's a much better way of doing it. All right, so here you go. Have a look at that. All right, now going back to the last warm-up we did, okay, these were on logarithms, and these were some pretty tricky logarithms. During office hours on Friday, I started going over this problem. So I just want to walk you through it, and we'll finish it up, and then we'll do the other one. Okay, so I noticed that I have 2 logarithms of base 8 that are being subtracted. So I'd like to put them together, but I can't do that when I have this coefficient here. Okay, I can't just do x divided by 1 over x because of this coefficient. So to get rid of that coefficient, I'm going to move it back up here. I'm going to use the power rule going backwards. So I'm going to make it back into a power. Now I can use my difference rule. Okay. As long as these don't have coefficients in front of them, we can use the difference rule. So now they're ready to go. So I know I can do x divided by 1 over x squared. So that's what I did here. I used my difference rule. And then when I have a fraction inside of a fraction, I like to rewrite this fraction bar as division. So I have x divided by 1 over x squared. I went ahead and I just multiplied this out. So 1 over x squared means 1 over x times 1 over x, which is equal to 1 over x squared. Okay, so I just simplified that to 1 over x squared. When I have divided by a fraction, I change it to multiplying by the reciprocal. The reciprocal of 1 over x squared is just x squared. So then this becomes log, let's bring it over here. So now I have log base 8 of x cubed, because x times x squared would be x cubed, is equal to 1. And now I'm stuck. So when I'm stuck and I'm in a logarithm, change it to exponential form. So 8 to the power of 1 is equal to x cubed. 8 to the power of 1 is equal to x cubed. So while 8 is the same as 2 cubed, so I can change this to 2 cubed is equal to x cubed. Therefore, what does x have to be? X has to be 2. Okay, so x is equal to 2, because if the exponents are the same, then the bases have to be the same. And there you have it. Okay. This one, yeah. I was going to say there's another way we could have gotten to this answer as well, but that's okay. One way is good enough. All right, notice on this one, they don't have the same base. So that is a problem. How can I make these have the same base? So I want to use my change of base formula. So did I have you do one of those before? I think I had you do one of those on like a homework assignment or in the notes or something. Okay, so I want these to have the same base so that I can use my addition rule. All right, so I want to change, let's see, can I change this one into a base of 2? So let's see if I can do that. I want to try and do a change of base. I have log base 8 of x, and I want to rewrite it in terms of log base 2, so it matches this one. So what we do is the change of base rule says that I can rewrite any logarithm with a different base by just doing this. I take the value, put it on top, and take the base here, put it on the bottom. Bam. So now I've rewritten log base 8 of x as a logarithm with base 2, but that's kind of a mess. Can we simplify this? Yes, we can. This right here, log base 2 of 8, we can simplify this. 2 to what power equals 8? Okay, 2 to the third power equals 8. So this right here just simplifies to a 3. Log base 2 of 8 is just equal to 3. Okay, 2 to what exponent equals 8? The exponent is 3. This represents an exponent. So then I have this. Okay, and that still looks kind of ugly, so how can we simplify that? Divide by 3 the same as multiplying by a third. So this is the same as 1/3 log base 2 of x. Okay, so I want to show you a really nifty shortcut right now. Now that I did it the long way, I want to show you a nifty shortcut. Log base 8 of x, I can rewrite 8 as 2 to the third. And then if I can take this exponent here and I can move it out in front as a fraction, do the reciprocal. That's the shortcut. Here's doing it the long way, proving that it works. And here's the little shortcut. If you can rewrite, oh my God, you can't see any of that. I just did all that off screen. I am so sorry. Okay, let's try this again. By the way, this is scratch paper. If I have a base that I can rewrite it in terms of another base, so 8 I can rewrite as 2 to the third, then you can take that exponent and take the reciprocal and just move it out front. Make it the coefficient. And then you're left with log base 2 of x, log base 2 of x. Okay, so here is where I proved it, but here's kind of the shortcut. If you can rewrite this as an exponent, a base with an exponent, then you can just take that exponent and bring it out front as the reciprocal. But here's doing it the long way, which shows that it actually works. All right, so that means I'm going to rewrite this puppy right here as 1/3 log base 8 of x. Okay, so I'm rewriting that in terms with a base of 2. Sorry, I just put an 8. That should have been a base of 2 plus log base 2 of x is equal to 4. Now, notice I have like terms here. I have 1/3 log base 2 of x plus 1. I can put the invisible coefficient in front. These are like terms. See, this is the same as this. They're like terms, so I can add these together. 1/3 plus 1 would be 4/3. So I have 4/3 log base 2 of x equals 4. I'm trying to get the x by itself, so let's get rid of times by 4/3. To get rid of times by 4/3, I'm going to multiply by the reciprocal, which is 3/4. So these cancel out. I'm left with log base 2 of x is equal to, the 4's cancel out, I'm left with 3. And now I'm stuck. So when I get stuck, change the form. Change it to exponential form. So I'm going to have 2 to the power of 3 equals x. 2 to the third equals x. So x is equal to 8. Bam. There you have it. Okay, so that was the warm-up from last week. All right, so today's warm-up right here, I'm now going to do an example for your notes of more revolution, and it's going to be around the y-axis. Okay, and then there will be a math-based assignment. Bye-bye.